Chapter 3.3, Completing the Square. In general form, it's not obvious what the vertex is, and it can be difficult to solve for x-intercepts. To get around this, we can complete the square to change the quadratic into vertex form. Completing the square. First, make sure your equation is in general form before you start. Step 1. Group the x squared and x terms in brackets with a space after the second term, and then close the brackets and write the constant term outside. Step 2. If there's a coefficient in front of the x squared, you need to factor it out of both terms in the brackets. If the coefficient is 1, go on to the next step. Step 3. Take the coefficient of the second term, half it, then square it. Step 4. Using the number you got from step 3, add it in the space in the brackets and subtract it outside the brackets. If you factored out a coefficient in step 2, you must multiply this to the number you subtract outside the brackets. Step 5. Factor the trinomial in the brackets. It becomes a binomial squared, and calculate the constant on the outside of the brackets. That was a lot of information. Let's try it so you get the idea. Example y plus 6x equals x squared plus 10. First, we need to make sure it's in general form before we start. This is not in general form because I have y plus 6x. I need to have just y. So I'm going to subtract 6x. That would go in the middle because I want x squared, then x, then constant. So I get y equals x squared minus 6x plus 10. Now I can do step 1. I want to group the x squared and x terms together in brackets. So y equals bracket x squared minus 6x. Leave a space, and then outside the bracket, put the constant, so plus 10. Step 2, if there's a coefficient in front of x squared, factor it out of both terms. If the coefficient is 1, go on to the next step. The coefficient in front of x squared would be a 1, so I can move on to step 3. Take the coefficient of the second term, half it, and then square it. So this was step 1. We don't need to do step 2, so we're moving on to step 3. I'm going to take the coefficient of the second term, which is negative 6, divide it by 2, and then square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. Step 4. Using the number you got from step 3, add it into the space in the brackets and subtract it outside the brackets. So we have y equals bracket x squared minus 6x. Then we're going to add 9 inside the brackets, close the bracket, then we have our plus 10. And then we are subtracting 9 outside the brackets. The reason we're doing that is because we can't just add 9 to an equation and have it be the same equation. So to negate that, we subtract 9. If we add 9 and subtract 9, then we're really doing nothing. So it's a way to manipulate the equation, but not change it. Step 5, factor the trinomial in the brackets and calculate the constant on the outside of the brackets. Y equals, we factor x squared minus 6x plus 9. It's going to factor to a binomial squared because of the way that we get the number when we do step number 3. We're ensuring that the trinomial is a perfect square trinomial by dividing the middle term by 2 and then squaring it and then adding that number in here. So we've made a perfect square trinomial, and perfect squared trinomials factor to a binomial squared, let's see what this one factors to. We would need two numbers that multiply to 9 and add to -6. That would be -3, -3, -3, -3. So they're both the same. They're always going to be the same because it's a perfect square trinomial. Then it factors to x minus 3 times x minus 3, or x minus 3 squared. And on the outside, we have plus 10 minus 9, which equals plus 1. And there is a shortcut to factoring perfect square trinomials as well, because we know when we do the process to complete the square, the trinomial we end up with is going to be a perfect square trinomial. Then we can just take the square root of the first term, so square root of x squared is x, that becomes the first term in the binomial. Square root of the last term, square root of 9 is 3, that becomes the second term in the binomial. And then the sign from the middle term in the trinomial becomes the sign in our binomial. The reason we want to be able to write a quadratic in vertex form is when we're asked to algebraically solve for the vertex. So from this form, now that we've completed the square and we've put it into vertex form, we can say that the vertex of this parabola is at the point x is 3. Remember, it's opposite of what it shows in the function. So x minus 3 means that the x value of the vertex is positive 3, and then y is positive 1. I also know that this quadratic opens upward because, remember, a tells us if it opens up or down depending on if it's positive or negative. Since there's nothing in front of x squared, it's a positive 1. A being positive 1 means that our parabola is going to open up. So I could draw a very quick sketch of this parabola. The vertex is at 3, 1, 1, 2, 3, and 1. So here, and it's opening up. I also know when a parabola is written in general form, the c value, recall, is the y-intercept. So I also know the y-intercept. I don't really have positive 10 for the y on here, but it's going to look something like this. Example, y equals x squared plus 8x plus 7. It's in general form already, so that's fine. We can move on to step number 1, where we group the x squared term and the x term together. So y equals bracket x squared plus 8x, leave a space, close the bracket, and then put the constant term outside. The coefficient in front of x squared is just a 1, positive 1, so we don't need to factor anything out. We can move on to step number 3. In step number 3, we take the coefficient from the second term, we divide it by 2, and then we square it. 8 divided by 2 is 4. 4 squared is 16. In step 4, we take that number and put it into the space in front of our bracket. So x squared plus 8x and then plus 16. We add it inside the brackets. Then we have our plus 7 and we subtract 16 outside the brackets. Because remember, you can't just add 16 because then you've changed the function. It's not the same function anymore. So we add 16 in the brackets. We subtract 16 outside the brackets, and then we've really added nothing. Now that we've done this process, the trinomial is a perfect square trinomial. We can factor that to a binomial squared. We take the square root of the first term, x squared, which is x. We take the square root of the last term, 16, which is 4. That binomial is squared. We take the sign from the middle term, which is positive 8x. so it becomes x plus 4 squared. And then we calculate the constant on the outside. 7 minus 16 is minus 9. There's our quadratic in vertex form. So we can tell that our vertex is at x is negative 4, since the equation is x plus 4 and the x value is opposite. And then y is negative 9. We can tell the direction of opening. The a value in front of x squared would be positive 1, so it's going to open up. Then I could do a quick sketch of my parabola and see where my vertex is in terms of quadrants. Negative 4, negative 9, so let's say that that's about here. Negative 4, negative 9. And the y-intercept from general form, the constant term is 7, so about here. So there's a quick sketch of our function, and we can see that our vertex is in quadrant 3. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this vertex is in quadrant 3. Next one, y equals 3x squared minus 18x plus 26. It's in general form, so I can go ahead with step number 1. Y equals bracket, group the first two terms, 3x squared minus 18x, leave a space, close the bracket, plus 26. Step 2. We do have a number in front of x squared, it's 3, so we need to factor 3 out of both of those terms. Then we get y equals 3 bracket x squared. Negative 18 divided by 3 is negative 6, so negative 6x. Leave a space, close the bracket, plus 26. Step 3, take the middle term, coefficient, divide it by 2, and square it. That's negative 3 squared, which is positive 9. Step 4, add the number from step 3 inside the brackets. Y equals 3 bracket x squared minus 6x plus 9, close bracket, plus 26. Subtract it outside the brackets, but because we had a number in front of x squared that we factored out in step 2, we have to make sure we multiply that to the negative 9. So times 3. The reason is because when we look at what we've added here, we added 9, but there's a 3 in front of the bracket. So that means distributive property 3 times each of those terms. So we're actually adding 3 times 9. So when we subtract, we need to subtract 3 times 9 as well. Step 5, we're going to factor this trinomial. Y equals 3 bracket square root of x squared is x, square root of 9 is 3, the sign from the middle term is negative, close bracket, squared, don't forget that squared, and then we have plus 26 minus 27, 9 times 3 is 27, and then finally simplify the constant term. Y equals 3 bracket x minus 3, close bracket, squared. 26 minus 27 is negative 1. This tells us that our vertex is at an x value of positive 3 and a y value of negative 1. We could draw a quick sketch. positive 3, negative 1. Let's say that's about here. And it's opening up because a is positive 3. And the y-intercept is at positive 26, which is probably above my graph. So it looks something like this. And our vertex would be in quadrant 4. Example, y equals x squared plus 5x minus 4. It's in general form, so we can go ahead with completing the square. Step 1, group x squared and x squared plus 5x, leave a space, close the bracket, minus 4. Step 2, there's no number in front of x squared, so we go on to step 3. Take the middle term, divide it by 2, and square it. 5 divided by 2 is 2.5. I'll leave it as a fraction. So 5 over 2 squared, that would be 5 squared, which is 25, over 2 squared, which is 4. Step 4, put that number into the function, y equals bracket x squared plus 5x plus 25 over 4, close bracket, minus 4 minus 25 over 4. Step 5, factor the trinomial. Square root of x squared is x. Square root of 25 over 4 would be 5 over 2. Square root of 25 is 5. Square root of 4 is 2. The middle term, 5x, has a positive in front of it, so plus. And then square that binomial. And minus 4 minus 25 over 4. I'm going to use my calculator. Negative 4 minus bracket 25 divide 4, close bracket. You can enter it as a fraction as well. And we get negative 10.25. I'm going to change that to a fraction. Math, enter, enter. And I get negative 41 over 4. So minus 41 over 4. Then the vertex is at negative 5 over 2, since it's x plus 5 over 2, and negative 41 over 4. And we can do a quick sketch. Again, our a value is positive 1, so it's opening up. This time our y-intercept is at negative 4. So negative 4 for the y-intercept. The vertex is at x equals negative 5 over 2, which is negative 2.5. Let's say that's about here. And negative 41 over 4, which is just a little more than negative 10. So we'll say that that's about there. And then it looks something like this. And our vertex is in quadrant 3 this time. Example, y equals negative x squared plus x minus 4. It's in general form, so we can go ahead with completing the square. Step 1, group our x squared and x terms together. Negative x squared plus x, leave a space, close the bracket, minus 4. Step 2, factor out whatever's in front of x squared, which in this case is a negative 1. So y equals negative 1 bracket, that leaves x squared, and then minus x, leave a space, close the bracket, minus 4. Step 3, take the middle term, which is -1, divide it by 2, and square it. That gives us -1 squared is +1, and 2 squared is 4, so 1/4. Step 4, put that number into the equation, y equals -1 bracket x squared minus x, add it inside, plus 1/4, close the bracket, minus 4, and then subtract it outside, minus 1/4. And remember, because we factored a number out of the brackets, we have to multiply that number here. So times -1. Step 5, factor the trinomial. Y equals negative or -1, bracket, the square root of x squared is x, the square root of 1/4 is 1/2. Square root of 1 is 1, square root of 4 is 2. The middle term has a negative for the sign, so we have a negative for our binomial. Close the bracket, the binomial is squared. Then we have -4, and -1/4 times -1 would be positive 1/4. Then I just want to simplify the constant term. Y equals negative bracket x minus 1/2, close bracket, squared, and use my calculator. I have -4 plus fraction 1/4 gives us -15/4. Which I can change to a decimal, which is -3.75. I'm not sure why the calculator is not saying negative, but just an issue with this calculator app. So for graphing purposes, that the decimal would help me, but I'll leave it as a fraction for the function. Then we know our vertex would be at x is positive 1/2, since it says x minus 1/2 in the equation, and y is -15/4. I could do a quick sketch. This one had a negative a value. A is -1, so it's going to open down. And the constant term in general form is -4. So the c value is -4, which means the y-intercept is -4. Then we have a vertex at 1/2 and -15/4, which is just above the y-intercept. So if this is x equals 1, then 1/2 and about here. And we can attach our point, so it looks something like this. Our vertex is 1/2 and -15/4, and it's in quadrant 4. Example, y plus 1.5x equals -0.5x squared. I need to put it in general form first, so I'm going to subtract 1.5x from both sides. That gives me y equals -0.5x squared minus 1.5x. Now it's in general form. I only have two terms. I don't have a constant, but that's okay. It would just be plus 0. So my constant term is 0. Step 1 is to group the x squared and x terms together, but They are the only terms, so that's really done. Step 2, we want to factor out the number in front of x squared, which is negative 0.5. Y equals negative 0.5, bracket x squared, and then negative 1.5 divided by negative 0.5 gives us positive 3, so plus 3x, and leave a space, and then close the bracket. Step 3, take the second term, coefficient, divide it by 2, and square it. We'll leave it as a fraction, and we'll square it. 3 squared is 9, 2 squared is 4, so 9 over 4. Step 4, put that number into the function. Y equals negative 0.5, bracket x squared plus 3x plus 9 over 4, close bracket, minus 9 over 4. Remember, because we have a number factored out of the brackets, we need to multiply that number here. So times negative 0.5. Step 5, let's factor the trinomial. Y equals negative 0.5, bracket, the square root of x squared is x. The square root of 9 over 4 is 3 over 2. Square root of 9 is 3. Square root of 4 is 2. The middle term from the trinomial has a plus, and the binomial squared. Then the outside, negative fraction 9 over 4, move out of the fraction, times negative 0.5, gives us 1.125 as a fraction, that is 9 over 8. Our vertex is at x would be negative 3 over 2, since it's x plus 3 over 2 in the equation, and y would be 9 over 8. We have a negative a value, which means the graph opens down, and we have a y-intercept at 0, since c equals 0. We can do a quick sketch. Negative 3 over 2, that's negative 1.5, and 9 over 8, that's just above 1, so about here for the vertex. And then we have a y-intercept at y equals 0, so it looks something like this. And the vertex is in quadrant 2. Let's try some word problems. A sporting goods store sells water bottles for $8. At this price, their weekly sales are approximately 100 items. Research says that for every $2 increase in price, the manager can expect the store to sell 5 fewer bottles. What selling price will give maximum revenue? So this is what we call a revenue problem. Pretty much every revenue problem is going to be set up and solved in the same way. Revenue in general, we'll call R, equals the number of items sold times the price per item. So if the water bottles are $8 each and you sell 10 of them, then 8 times 10 equals 80 is your revenue. When we have questions like this, where we're going to change the price and the amount sold, We're going to have two binomials, so two sets of brackets, just like we did above. The beginning of each bracket is going to be the starting amount. Their weekly sales are approximately 100 items. So that's the starting amount for items, number of items sold. And then for price, the water bottles are $8. That's the starting price. So that goes at the beginning. Then the end of each bracket is the change. Research says that for every $2 increase in price, the manager can expect the store to sell 5 fewer bottles. So we could sell 5 fewer bottles, that would be minus 5. And that's for an increase, which would be plus, of $2. Now notice it doesn't say we're going to increase the price once or twice or whatever. It just says for every $2 increase. So this is where the variable comes in. We don't know how many times we're increasing the price, so we have to do plus 2x. And also, every time we increase the price, the number of items sold decreases, so we have to put in the same x at the end of the first bracket. So this is our revenue function. Right now it's in factored form. It's factored to two binomials. We need to put it in general form because we want the maximum revenue. Okay, so we need the vertex. To get the vertex, we can algebraically change the quadratic from general form to vertex form by completing the square. So to do that, we need this in general form. So we're going to multiply the two binomials together. So we get r equals 100 times 8 is 800. 100 times 2x is 200x. Negative 5x times 8 is negative 40x. And negative 5x times 2x is negative 10x squared. Let's write the x squared term first. So negative 10x squared. Then we have 200x minus 40, which is plus 160x. And then plus 800. Now it's in general form, and we can complete the square. So step 1, let's group the first two terms together, negative 10x squared plus 160x, leave a space, close the bracket, plus 800 outside the bracket. Step 2, factor out the coefficient in front of x squared, which is negative 10. R equals negative 10 bracket, that leaves x squared. Positive 160 divided by negative 10 would be negative 16. Negative 16x, leave a space, close the bracket, plus 800. Step 3. Take the second term coefficient, divide it by 2, and square it. That is negative 8 squared, which is positive 64. You can use your calculator if you need to. Bracket, negative 8, close bracket, squared is 64. Step 4. Put that number into the function, negative 10 bracket x squared minus 16x. Add it inside the brackets, close bracket, plus 800. Subtract 64 outside the brackets, but also multiply it by the coefficient that is in front of the brackets. So times negative 10. Step 5. We want to factor the trinomial and simplify the constant. So negative 10 bracket square root of x squared is x. Square root of 64 is 8. Can use your calculator if you need to. Square root of 64, 8. And the middle term in the trinomial is negative, so x minus 8. The binomial is squared. Then we have 800 minus 64 times negative 10, which is 1,440. So plus 1,440. Now we can get the vertex. The vertex would be 8. Since it's x minus 8, it'd be positive 8. And the y value is 1,440. So what do these numbers mean? Well, our y value is our revenue, right? This is our y in this question is r, so revenue. And our x value, the x was the number of times we're going to change the price. So in this case, it was the number of times we're increasing the price. And the y value is the max revenue. The question says, what selling price will give the maximum revenue? So we want to know what's the new price of the item. If we look over here, the new price of the item is 8 plus 2x. Because that represents the price per item. So it started as 8, but we're going to add $2 x number of times. And we just determined that x is 8. So we can calculate the new price. It's 8 plus 2x, which equals 8 plus 2 times 8, because in our vertex, x is 8. And 8 plus 2 times 8 is 24. So $24 for a bottle, which sounds ridiculous to me, but maybe it's one of those fancy metal bottles. So a little note for revenue problems. The x value of the vertex is always the number of price changes and the y value is the max revenue. So the store will earn their maximum revenue, which is $1,440, when they increase the price 8 times to a new price of $24. Example, a farmer wishes to enclose a rectangular region bordering a river, and he wants to divide the region into 2 equal parts. What is the maximum area that can be enclosed with 600 feet of fencing? So this is another type of problem that is very common, and it is called an area problem. So we've seen revenue problems and now area problems. The first thing I recommend is to draw a picture. So we have a rectangular area and it's bordered by a river. So what that means is we don't need to put a fence along the river, because the river keeps the animals from leaving or whatever from getting in. Okay, so we don't need a fence there. This would be the length of the rectangle, and then we have the width. It also says he wants to divide the region into 2 equal parts. So he's going to split this down the middle with fencing as well. So we actually have 3 widths. What is the maximum area that can be enclosed with 600 feet of fencing? So we know that the farmer has 600 feet of fencing. This tells us that we're going to use 600 feet of fencing. So the amount of fencing would equal the length plus 3 widths, because these are all things that we need to fence. We need to fence 1 length, and we need to fence 1, 2, 3 widths. So those 4 things, 1 length and 3 widths, add up to the total amount of fencing. And we know that the total amount of fencing is 600 feet. So 600 has to equal length plus 3 width. We want to know about the area. So area of a rectangle is length times width. I don't know either the length or the width. So I can't use 2 variables and be able to solve. I have to be able to write it in terms of 1 variable. That's where having 2 equations for area problems is necessary. We're going to use this sort of perimeter type equation to rewrite either L or W in terms of the other one. So I'm going to rewrite L in terms of W. If I subtract 3W from both sides to isolate L, then I get 600 minus 3W equals L. So now, instead of writing L here in the area formula, I could replace that with 600 minus 3W because it equals L. So if I do that, I get A equals 600 minus 3W times W. Now I have only 2 variables. I have A and I have W. Just like normally I have X and I have Y. Now I can change this into vertex form and find my vertex, which would be my maximum area. So first I need it in general form. I'm going to multiply the W into the brackets. I get A equals 600W minus 3W squared. Then I'm going to rearrange that so it's in general form, negative 3W squared plus 600W. And now I can complete the square. So step 1 is pretty much already done for me. I don't have a constant term, so just brackets, leave a space at the end of the brackets. Step 2, I need to factor out the negative 3. A equals negative 3 bracket W squared. 600 divided by negative 3 should be negative 200. Yes, so negative 200W, leave a space, close the bracket. Step 3, take the coefficient in front of the second term, negative 200, divide it by 2, and then square it. Negative 200 divided by 2 is negative 100. Squared is bracket negative 100, close bracket, squared gives us 10,000. Step 4, plug that number into our function. A equals negative 3 bracket W squared minus 200 100W plus 10,000 inside the brackets minus 10,000 outside the brackets and times -3, because we remember that we factored out -3 from the brackets, so we have to multiply that here. Step 5. Factor the trinomial. Square root of w squared is w. Square root of 10,000 is 100. You can use your calculator. Square root 10, 1, 2, 3, 10,000 is 100. The middle term sign is negative, so negative, and then close bracket squared. Then negative 10,000 times -3 is positive 30,000. You can use your calculator. Positive 30,000. So our vertex is at x would be positive 100 and y would be 30,000. What do these represent in terms of the question? Well, our variables were a and w, so this would be w, which is the width, and this would be the max area possible for this question. So when the width is 100 feet, we get an area of 30,000 feet, which is the maximum area we can create for this situation. Maximum area is 30,000 feet squared. And they didn't ask us for this, but let's write the dimensions of the rectangle as well. So width is 100 feet, and then length we can calculate because we have this equation here for length. Length is 600 minus 3w. So length equals 600 minus 3w, which equals 600 minus 3 times 100, which is 600 minus 300. 600 minus 300 is 300. So 300 feet is the length. And the last type of word problem is one where we are given a quadratic equation and asked for a maximum. Example, an explosive is launched at a snow slope. The equation for the explosive's height, h in meters, at time t seconds is h of t equals negative 4.9 t squared plus 19.6 t plus 58.8. What is the maximum height of the explosive? So we already have our equation. We don't need to make it, which is nice. We just want to put it into vertex form. So first of all, h of t equals, group our first two terms, so negative 4.9 t squared plus 19.6 t, leave a space, close the bracket, plus 58.8. Step 2, factor out the number in front of t squared, which is negative 4.9. h of t equals negative 4.9 bracket t squared, definitely need my calculator, 19.6 divided by negative 4.9 is negative 4. So negative 4t, leave a space, close the bracket, plus 58.8. Step 3, take the middle term coefficient, -4, divide it by 2, and then square. -4 divided by 2 is -2. -2 squared is +4. Step 4, plug that into our function, -4.9 bracket t squared minus 4t, add 4 inside, close the bracket, plus 58.8, subtract 4 outside, but also multiply it by this coefficient that we factored out, so times -4.9. Step 5, factor the trinomial and simplify. -4.9 times the square root of t squared is t, the square root of 4 is 2, the symbol from the middle term is negative, close bracket, squared, and then 58.8 minus 4 times -4.9 is 78.4, so plus 78.4. Then the vertex would be 2, since it's t minus 2, then the x value is 2, and 78.4. What do these values mean for this question? Well, our variables in this question were t for time in seconds and h for height in meters. So this is t, time in seconds, and this is our height in meters. What is the maximum height of the explosive? So we can answer the question. The max height of the explosive is 78.4 meters. That's the answer to the question. We could also say at what time the max height is. And happens 2 seconds after launching. They didn't ask for that in this question, but in other questions it could ask you at what time the explosive or the object was at its maximum. It could ask you for both the height and the time. You just have to make sure you read the question carefully and answer what it's asking for. That brings us to the end of the Chapter 3 notes.